Hello and welcome to this video on multiplying rational expressions, or multiplying fractions, where each fraction is made up of a numerator that is a polynomial and a denominator that is a polynomial. Right, that is what it means to be a rational expression, right? A ratio of two polynomials. All right, so let's begin. Several examples of this, where I'm asked to multiply and simplify a pair of rational expressions. Now, if you recall, when you multiply two fractions, say a over b times, right, little dots multiplication, c over d, when you multiply two fractions, you simply multiply the numerators. So you have a times c would be the new numerator, and then multiply the denominators. B times d would be the new denominator. And then you simplify this fraction or rational expression as we've done in previous videos, but or again, you can look up other videos where you're simplifying a rational expression. So an example here would be if I had 2/3 times let's say 15/14 or something. Okay. Now you could do it this way, where I just simply multiply the numerators. 2 times 15 is 30, and then the denominator is 3 times 14 is 42, and then simplify, where we factor the numerator. 30, when you factor it completely, is 2 times 3 times 5, and the denominator, when you factor it completely, is 2 times 3 times 7, and then you cancel out common factors, right? 2 divided by 2 is 1. They both have a numerator and denominator both also have a factor of 3. So those become like 1, right? You cancel out ones, they say. And all I'm left with in the numerator is a 5. All I'm left with in the denominator is a factor of 7. And there we have 5/7. Alright, so I'm going to do something similar to this, but not necessarily in this order, when we have variables involved, right? So like this example over here where you have p's, variable p involved. We're going to go from like this step to this step first, right, where I do all the factoring, break everything down to prime factors, and then do simplification. And one of the note I want to make here is that when multiplying fractions, like up here, the values of the denominators cannot be 0, right? B cannot be 0 and D cannot be 0. So I'll just make sure to point that out as we work through some examples here. Just make sure that you never have a denominator equal to 0. Right? So when you're stating what can I plug in for the value of p, you may already see it, but right here p cannot be 3. Right? 2 times 3 would be 6, minus 6 would be 0, and I'd have a denominator of a fraction that's 0. I'd be dividing by 0 that is undefined. So I'll make a note of that as well. But you could plug in anything else. Right? You could plug in anything else for p you wished, and you'd be fine, as long as you don't divide by 0. Okay. So I'll write out some steps for this. First, we're going to factor each numerator and denominator completely. Okay. So this is a bunch of polynomials. If you want to look back at my videos on factoring polynomials, sure. go ahead and do that, or look for better ones out there. I'm sure you'll find them, or read your book on sections on factoring. So the numerator of this fraction, p squared minus 9 over 5, is a difference of squares, right? So p squared minus 9, that factors to p minus 3 times p plus 3, right? Or p plus 3 times p minus 3, whatever you want. And the denominator is simply the number 5. So that's already prime, that's already factored completely. Great. So I've factored the numerator and denominator of this fraction first, times, and then now you can leave numerical factors the way they are if you don't want to keep going with the factoring, but I'm going to break down everything completely. So this is 25 times p, right? So two factors, 25 and p. We can break down 25 more. 25 is 5 times 5. Now if you want to write 5 times 5, that's fine, or 5 squared, right? 5 to the second, that's fine too, and then times p. So that's 25p, factored completely, where the coefficient is factored completely. And then the denominator, 2 times p minus 6, has a greatest common factor of 2. Alright, so I'm going to pull that out. And when I remove a factor of 2 from the denominator, that looks like this. 2 times, and then the factor remaining would be p minus 3, right, to give me 2p minus 6. Okay, so first comes the factoring part. I'm going to factor everything completely. Next, I'll bring up a new sheet here. Next, we're just going to actually multiply. Alright, so as I put up here, right, when you multiply two fractions, you simply multiply the numerators and multiply the denominators. So all this step is really just me listing the factors that are in the numerator and the factors that are in the denominator, next to each other. So this product here, the numerator is p minus 3 times p plus 3 times 5 times 5 times p. And in a product, you can arrange factors any way you want. A times b times c is the same thing as b times a times c, and that's the same thing as c times a times b, and so on. You can rearrange factors however you wish. So my personal preference, and you'll see this in most texts, is that they'll put the numerical factors first. So in the numerator I have factors of 5 and 5, right, my numerical factors first. And then, I've got, again, it doesn't matter what order you put the factors in. I'll put the 5 times p first, and then times, and then p minus 3 times p plus 3. And I guess I really don't need all the dots here, but that indicates multiplication. And that whole thing is the new numerator now. And I'm going to do the same thing for the denominator. Again, just multiply the numerators, just writing out what factors are in the numerator really. And now we're going to multiply just the denominators. And I'm going to list those factors. And let's see, we have a 5 times 2 times p minus 3. Those three factors in the denominator. And I'm going to put them in this order. I'll put the 2 first, times, and then the factor of 5, and times, and then that factor of p minus 3. Alright. Okay. I guess, and one thing I should have mentioned earlier too is after factoring, we can also state some values of the variable that we cannot use, right? So like look at your denominators, and remember that denominators cannot be equal to 0. Right? Denominators cannot be 0. So what makes this denominator 0, I mentioned it earlier, would be when p is 3. So p cannot be 3 throughout this entire process. If I were to replace the value of p with 3, we would divide it by 0. That's a problem. Anything else is fine. And then this denominator over here is just 5, right? That's never going to be 0. So the only value that's not allowed is 3. And I'm going to keep writing this every step of the way. You know, this product is equal to this product is equal to this product, and the whole way down I make a note to myself, the value of p can never be replaced with 3. Alright, now I've multiplied the fractions, multiplied the numerators, multiplied the denominators, basically just listed the factors, right, with a big fraction bar. And then lastly, we'll do the simplification. This is where we cancel any common factors in the numerator and denominator, right? This is the simplification part. So looking at this, I'm noticing the numerator and denominator both have a factor of 5. So that's those. Technically, they become 1. 5 divided by 5 is 1. So just make sure that if you eliminate an entire numerator or an entire denominator, there's still a factor of 1 technically there. So the 5s, I also notice there's a common factor of p minus 3. So those become, 1. Those cancel. And that's it. That's all I'm noticing. So when all's said and done here, this product that we started with, right, when I was asked to multiply these two fractions, the resulting product will be equivalent to, let's see, 5 times p times the quantity p plus 3 in the numerator. All that is the numerator divided by, and then in the denominator I'm left with just a factor of 2. And one more time, off to the side, I'm going to make note of the fact that the only way this is going to be true is if I plug in a value of p that's not 3, right? And there we go. This would be considered by most texts a simplified version of the product of these two fractions. Now, if you'd like, you can get rid of the parentheses by distributing, take 5, this would be 5p times p, so 5p squared plus, and then 5p times 3, making it 15p. So you could also have written it this way, right? 5p squared plus 15p in the numerator, all of that divided by 2 in the denominator. But again, make a note, from earlier on that p cannot be 3. And if you want to test this out, is this true? Is the product of these two fractions equal to this fraction? Plug in some values for p. If they truly are equal, they should have the same value no matter what you plug in for p. Again, as long as it's not 3, right? Because if you plug in 3 up here, you'll be dividing by 0 in this second fraction, and that won't make any sense. That'll be undefined, so it can't possibly be equal to this other fraction over here. So let's just test that out. Why not? So I'm going to test it. Let's plug in, I think an easy one would be, let's test. How about if p was 0? All right, now if p was 0, look at the top one, alright? So we'd have negative 9 divided by 5 times, and then 0 divided by negative 6. So the numerator would be 0 when I multiply the numerators. The denominator would be negative 30. And remember, 0 divided by any non-zero number is 0. And let's see, do I get the same thing here? When I look at the 5 times p plus 3, that'd be 5 times 0 times 3, all divided by 2. Well, yeah, the whole numerator there's a factor of 0. Anything times 0 is 0. So it'd be 0 divided by 2, which would indeed be 0. These are the same. The product of these two fractions and this fraction here have the same value when p is 0. And it'll be that way no matter what you plug in, again, as long as it's not 3. How about when p is, I'll just do one more. and this will be the only example I do this for. I'll just say to do it for other examples. When p is 1, right? When p is 1, look at the numerator. Look at this product up here, right? This is what we started with. If I plug in 1 for p here, here, and here, I get 1 squared is 1 minus 9 is -8 over 5 is that first fraction. And then this second fraction, 25 times 1 is 25 divided by, and then 2 times 1 is 2 minus 6 is -4. Okay, and now I can see some simplifying here. -4 and -8. -8 divided by -4 is +2. Alright, so this is like a 1 that becomes 2 and all that, and you can do some cross canceling here. So what I'm left with, oh, and also 5, pardon me, 25 over 5, 5 goes into 5 once, 5 goes into 25 5 times. So you see I'm left with 10. This ends up just being 2 times 5. And you could do it another way, right? Make this this would be -200 in the numerator divided by -20 in the denominator, and negative divided by negative is positive, and 200 divided by 20 is 10. So either way you're ending up with 10. Alright, so that's checking the original. Well, how about what we said it simplified to? Right? How about this fraction here? Let's plug in 1 for p, and hopefully we get 10 again. So this is 5 times p, so 5 times 1 times, and then this other factor is 1 plus 3, that's 4, and then divided by, and then the denominator is 2. 5 times 1 times 4 is 20, and then divided by 2 is indeed 10. Right? And again, that's just a couple examples. It should work out every single value I plug in except 3. For plug in a million, plug in a billion, plug in a third, a half, -5, and this product should be equal to this fraction right here. Okay, so let's look at some other examples. The next one I have is again another let's multiply and simplify the product of these two fractions. So I'm noticing all the polynomials are the way I like, where everything's in descending order. Right? X squared, x to the first, then nothing, then x to the first, then nothing, x to the first, no x, x to the first, no x. Every polynomial is in descending order. I didn't really mention that last problem, but you'll see some examples here where I'll have to change some things around to get the way I like. Alright, so first, the factoring. Alright, so I'm going to factor the numerator and denominator of each fraction. And then after I factor, I'm also going to point out to myself what is a value I cannot plug in for x. What are values that make these these denominators 0, this 6x plus 30 or x squared plus 3x minus 4. Alright, so first the factoring. Alright, so 2x plus 8 has a greatest common factor of 2. Right, so that comes out. And then when I remove that, there's x plus 4 left over, divided by. Then this is a quadratic trinomial here, x squared plus 3x minus 4. You can look up other videos on how to factor these, but I'm just going to kind of do it pretty quickly here. This would factor to x, and then I'm looking for factors of -4 that have the +3. I'd have to have +4 and -1, right? And you can double check, multiply these two, FOIL, right? You'd get x squared plus 3x minus 4 back. Alright, great. Done with the first fraction. Move on to the times, and then the second fraction, do the same thing. The numerator, factor it completely. The GCF is 7. When I remove 7, there's x minus 1 left over, divided by. And then the denominator, GCF, is 6. Remove the 6, and then what's left over is x plus 5. Alright, and even the 6 I'm going to break down further when I go over here. Okay, I'm actually going to rewrite this as 2 times 3. Right, break it down even further. Alright, so now the factoring step is done, and just beneath this I'll point out to myself that x cannot have a value. When I go to plug in values for x in this expression, can't divide by 0. Right? So nothing in the denominator can be 0. So x plus 4, this factor can't be 0, meaning x can't be negative 4. This factor, I don't want that to be 0 either. So x can't be 1. Right? 1 minus 1 would be 0. 6 is not going to be 0. 2 and 3 are not going to be 0. There's always 6. And then this other factor, x plus 5 in the denominator. I don't want that to be 0. So x can't be negative 5 also. So here are 3 values that would make this undefined, make me divide by 0, and I don't want that. But you can plug in anything else you wish. You can plug in 2, 3, 8, 18, a million, a billion, a third, negative 16, whatever. As long as it's not one of these 3, you're allowed to plug it in. Alright, so now comes the multiplication step, where I'm just basically listing the factors. I multiply the numerator, multiply the denominators, and we just get one big fraction. So in the numerator, I've got a factor of 2 times, and then there's a factor of 7. And I like to put the numerical factors first, times, and then there's this factor of x plus 4, times, and then this last factor up here, x minus 1. Okay, there's the numerator, right? The product of these two numerators, and then the denominator has these factors of 2 and 3. Right, the 6 I broke down to 2 and 3. Right, that's 2 times 3. And then there's the x plus 4 factor, the x minus 1 factor, and the x plus 5 factor. Alright, so this product, this big multiplication down here, that is the new denominator, right, when I multiply these two denominators. Alright, and then the last part, again, remember that x cannot be one of these 3 numbers in this. And then the last part is the canceling common factors in the numerator and denominator. I'm seeing they both have a factor of 2. They both have a factor of x plus 4. They both have a factor of x minus 1. And that looks like about it. Alright, so when all's said and done, I get the product of these two fractions will be equal to this fraction here, where my numerator is just simply 7. Right, that's the only factor left over in the numerator. And the denominator has the factors of 3 times and then x plus 5. And there you go. And then just again off to the side, just make sure I know that x cannot be negative 4, it can't be 1, and it can't be negative 5. But anything else, any other number is fine to plug in for x. And this is totally fine here where it's factored. If you would like, again, you can distribute the 3 and make the denominator 3x plus 15. Alright. And then if you want to test it, see if it works out a few times. Plug in a value for x that's not one of these. Right? Plug in 0, plug in 10, plug in a billion, right? Whatever you want, and see if the product of this fraction and this fraction is indeed equal to this fraction here. And it should be. I promise you it will be if I did everything correctly. Alright, so again, simplify, multiply and simplify these two fractions. Now here, this is one of those where I look at all the polynomials in the numerator and denominators of these fractions. This is in descending order, where you have highest power of x first and then it goes lower. Then here this is in descending order. But this one, right, 7 minus x, doesn't this is not in descending order. So I have a preference where I would like to put this in descending order. So I'm going to put that over here. I'm going to say put all my polynomials. You don't have to. It's just a suggestion. I prefer it. Put all polynomials in descending order, meaning put the highest power of the variable first and then keep getting lower and lower power terms after that. So I'm going to rewrite this as x minus 7 divided by x squared minus 9. Alright, those are already in descending order, times x plus 3, that's in descending order, divided by, and then down here, if I put the x term first, that'd be negative x, and then the other term, positive 7, so plus 7, negative x plus 7. I prefer this, personally. All right, so now the factoring part. Okay, so I've got, x minus 7 is simply x minus 7. Now if you want to put it in parentheses, that's fine. In fact, I'll do that. That doesn't factor any further, so that is the only factor in this numerator. Divided by x squared minus 9 factors further, right? That's a difference of squares, x squared minus 3 squared. So that factors to, x plus 3 times x minus 3. Again, separating factors using parentheses. Times, and then the other fraction, again, x plus 3. This doesn't really factor any further. There's no common factor at all to pull out or anything. So that's it. That's the only factor in this numerator. And again, just to indicate that it's the only one, that's all, that whole thing is a factor of the numerator, I'm going to put it in parentheses. Alright, now the denominator. Now I know the greatest common factor of negative x and positive 7 is 1, but the lead coefficient is negative, and again, if you've seen other videos of mine, you know that when my lead is negative, I like to pull out the opposite or negative greatest common factor. So the greatest common factor of these two terms is 1. I'm going to pull out negative 1. All right, in fact, I will put that in parentheses, negative 1, which you could have also just put a minus sign, right? Whenever you see a minus sign, technically it implies there's times negative 1. Like even here, when you see minus 7, that's negative 1 times 7, right? Negative 7. And, negative 1 times 3. So later I'll probably just put a minus sign. But I'm going to factor out negative 1 from this, negative x plus 7, and the factor remaining would be x minus 7. Right? If I redistribute, that would give me minus x plus 7. Right? Okay. And then below that, again, I'm going to point out the value of x cannot be equal, right? Values of x that I cannot plug in. Again, I'm only looking at the denominators. So this factor in the denominator, this x plus 3, can't be 0. So that means x can't be negative 3. This factor of x minus 3 can't be 0. I don't want that to be 0, so x can't be positive 3 either. The factor of negative 1, that'll never be 0, so I'm not worried about that. And then this factor of x minus 7, if I plugged in 7, that would be 0, so x can't be 7 either. Alright, so I'm pointing out all the values I cannot plug in when I check later if my statements are correct. Can't use negative 3, positive 3, or positive 7. But anything else would be fine. Alright. Alright, so now the multiplication part, where I just simply, again, just make one big fraction where I put the factors down. So the numerator has, if I multiply the numerators, I've got a factor of x minus 7 times a factor of x plus 3. In the denominators, my numerical factor is negative 1. Again, this time I'm just going to write a big minus sign, implying that there's a minus 1 there. So negative 1 times the quantity, x, the factor x plus 3, times there's a factor of x minus 3, and times a factor of x minus 7. Okay. And then now we cancel common factors. I notice they both have a factor of x minus 7, and they both have a factor of x plus 3. Now I had mentioned this earlier, but here it's actually happening. When an entire numerator or an entire denominator looks like it's canceled, remember there's still technically, these are becoming 1 when you cancel. Anything divided by itself is 1. So really I have the number 1 up top left over. It's not all gone. There's still technically 1 in the numerator. Okay, so I've got 1 in the numerator divided by, and then negative 1 times, and then this x minus 3, is the only factor left over in the denominator. And just off to the side again, I make a note to myself that x cannot be -3, +3, or +7. Now you can leave it like this. This is fine. It's just there's a typical standard that usually you don't have a negative number as a lead in your denominators. So if you'd like, you can move this around. If you like, you can have it like pop it up to the middle here in line with the fraction bar, and say we're just doing we have the opposite of 1 divided by, and then x minus 3. Right. So here you would plug in a value for x, and do whatever this is, and then take the opposite of that. Or you could also, instead of moving it to the middle, just move it to the top in the numerator, -1. So make that, -1 in the numerator divided by, and then when the negative is gone, you have, x minus 3 in the denominator. I guess of all three of these, I would prefer this one, but again, they're all the same. They all have the same value. And one more time, I'm going to say, just remember, remember the values you can't plug in. All right. So if you wanted to test it, right, and I can do one out loud real quick. If I wanted to test this, just plug in some values that are not these three, and see if this fraction is equal to the product of these two. So how about like 0? Right. Well, if x were 0, I'm just going to kind of say this. This would be -7 divided by -9. So 7/9 times, and then 3 divided by 7. Well, 7/9 times 3/7, the 7's would cancel, and you'd get 3/9 or 1/3. All right. This would be 1/3 if x were 0. And then down here, if x were 0, you'd have 0 minus 3, so -3 in the denominator, and then -1 divided by -3, negative divided by negative would be +1/3. Same thing here, you do 0 minus 3, you get a third, and then the opposite of that, you get -1/3, and then the opposite of that would be +1/3. And then here 0 minus 3 is -3, you take the opposite of that as +3. No matter how you plug it in and which one of these you do, you get +1/3. So the value of this product and the value of this are indeed the same when x is 0. And it would be that way for when x is 1, a billion, 5, a Google, 1/5, as long as you're not using -3, 3, or 7. All right, and I've just got a couple more here real quick. Now that we hopefully know what we're seeing, what we're doing here. I'm doing 15 minus 3a. That's not in descending order. I don't like that, so I'm going to rewrite that. Same thing with the 3 plus 2a. It's not in descending order. So I'm going to rewrite that as well. So this 15 minus 3a, I'll rewrite that so the a term is first, so -3a, and then the 15, +15. So I'm rewriting this as -3a plus 15, all over 7. Times, and then 3 plus 2a, again I don't particularly care for that, it's not in descending order, so I'll put the +2a first and then the +3 term second, so make that 2a plus 3. And then the denominator of this fraction is in descending order, so I'll leave it that way. All right, 2a squared minus 7a minus 15, fantastic. Alright, so now comes the factoring part. All right, so this numerator, the greatest common factor is 3, but the lead coefficient is negative. So I'm going to factor out -3. All right, so -3 comes out, and then when I remove -3, what's left over would be a minus 5. All right, and just multiply those, you'll get -3a plus 15 back. So that's that numerator factored, divided by 7 is prime, so just 7. Times, now this numerator, 2a plus 3, the greatest common factor is 1, lead coefficient's positive, so I'm not pulling out -1 or anything like that. This is it. That's as factor as it gets, and again, to indicate that that whole numerator is the only factor, all one factor, I'm going to put it in parentheses. All right, so 2a plus 3, that's the only factor of that numerator. Divided by, and then here we have a quadratic where again, if if you looked at other videos or whatever, you would see that I would do 2 times negative 15 is negative 30, and then I would think of what are factors of negative 30 that add up to negative 7. Okay, and that would just be, let's see, factors of negative 30 that add up to negative 7. Well, that'd be negative 10 and positive 3. All right, and I would rewrite the middle term as minus 10a plus 3a, and then factor by grouping, or you could do, some trial and error, guessing and checking. I'm just going to write what the factors are going to be real quick. One's got to have 2a, one's got to have a, and then I need a minus 5 over here and plus 3 here, right? And you can double check, take that gives me my minus 10a plus 3a, so minus 7a. Right, and then you got your 3 times negative 5 is negative 15 and all that. Great. And then before I multiply, again, I'm going to put down here the values that a cannot be equal to, right? The values that I cannot plug in for the variable. Now I'm only focused here on the denominators, right? The denominator can't be 0. So this factor 7, well, that's never going to be 0, so I don't have to worry about that. But 2a plus 3, right? 2a plus 3 in the denominator, that could be 0 when a is negative 3 halves, right? If you were to set that equal to 0 and then subtract 3 divided by 2. So a cannot be negative 1.5 or negative 3 halves. Also, this other factor of a minus 5 can't be 0. So a cannot be positive 5, right? If I were to plug in 5 for a, it'd be divided by 0. So just make sure that you know what you can't use, right? I can plug in anything else I want for a, just not these two. Alright, so knowing that now, let's do the multiplication. So I multiply the numerator. We've got negative 3 times a minus 5 times a factor of 2a plus 3. There's the numerator. And the denominator is the product of these two, right? So you have a factor of 7 times a factor of 2a plus 3 times a factor of a minus 5. And again, note that a cannot be one of these two numbers, and then we cancel common factors. So no number factors are the same. I'm seeing that they both have a factor of a minus 5, right? So you got those become 1, and 2a plus 3 over 2a plus 3 become 1. And really all I'm left with now is negative 3 in the numerator and 7 in the denominator. So the answer here, this product, this fraction times this fraction, would always simplify to negative 3/7 as long as you don't plug in negative 3 halves or positive 5. And let's check that. When a, again, a real quick one here would be to check when a is 0. Right, when a is 0, I'll even write this one this time. Right, when a is 0, which is not negative 3 halves or 5, so I'm okay. That first fraction up here would be 15/7 times, and then this one would just be 3 over negative 15. And do you see how 15 over negative 15 would just be, negative 1? So I do end up with, 3 over negative 7 or negative 3/7, like you said over there. Check. And that's when a is 0. And it should do that for any value you plug in for a. All right, not just 0, as long as you're not using negative 3 halves and 5. So plug in, negative 2, negative 1, 4, 4.9, 5.1, 5.5, 7, a million, a billion, a third, whatever. As long as it's not one of these two, this product will be negative 3/7. All right, and then lastly here I have one example where there are two variables. So it's a little trickier, but not exactly. You're still doing the same procedure. So I asked to multiply and simplify. I've got a squared plus 2ab plus b squared, right? So two variables, a and b. Then divided by 3a squared plus 3ab times, and then a minus b divided by a squared minus b squared. Now these are all in the order I would like. They're all in descending order. with a, right? See the powers of a are decreasing, the powers of a are decreasing, powers of a are decreasing. So they're all descending in descending order with one variable, which is what I prefer. All right, so let's do the factoring. All right, now a squared plus 2ab plus b squared. That's one of those perfect square trinomials. Again, see another video on that or read another section of the book, whatever. But that'd be a plus b squared, right, to the second. Or you could actually write them out, a plus b times a plus b, right? A plus b squared or a plus b times a plus b. Same thing. Divided by, and then this polynomial down here, these two terms have a common factor of 3a. So I pull out, there's a factor of 3, a factor of a, there's your 3a coming out. And then when I pull out 3a, what's left is a plus b. Right, you get your 3a squared plus 3ab. Great. Times, then a minus b, there is no common factor. I mean, GCF is 1. Lead coefficient's positive, so there's nothing really I can do with that one. So again, just to indicate that the whole thing is a factor, that's the only factor of the numerator, I'm going to put in parentheses. And then here we have a difference of two squares. A squared minus b squared would factor to a plus b times a minus b. All right. Now, here's the, I guess, trickier part. Remember earlier when I was stating, what can I use and what can I not use for a for a variable? Well, this one has two variables. But again, we're only focusing on the denominators. So here, 3 is a factor. That's never going to be 0, so don't worry about that. A can't be 0. Sorry, let me get a better marker here in a second. But from this one, we're seeing that a can't be 0. But also, a plus b can't be 0. That just, if you want to mess with this, that means that a cannot be the opposite of b, like subtract b from both sides here. So a can't be the opposite of b, so that means like I couldn't plug in like 4 for a and then negative 4 for b. They can't be opposites. Or I can't plug in 2 for a and negative 2 for b, right? So a and b can't be opposites. A can't be 0. The a plus b thing I've already done over here, so no need to write it twice. And then here's another factor, a minus b can't be 0. So that means a, and again, if I add b, a can't be equal to b either. All right, so a and b, so whatever you plug in for a and b here, they can't be the same, right? So I couldn't plug in, 3 for a and 3 for b in these fractions, because that'd be divided by 0. So they can't be the same. This says they can't be opposites, and additionally, you cannot plug in 0 for just the letter a. Okay, so I'll keep all that in mind. All right. So we multiply the fractions, just multiply the numerators. The factors are a plus b, and then a plus b again, right? Or again, if you want to write a plus b squared, that's fine, times a minus b. There's the numerator. And then multiply the denominators, you get, 3, times a plus b, times another a plus b factor, times an a minus b factor. And then now I have my numerator and denominator. I can cancel any common factors. So I'm seeing a common factor of a plus b, another common factor of a plus b. So in fact, they both had a plus b squared, and another factor of a minus b that they all have in common. And that's it. Now this is another case where an entire part of the fraction is eliminated, but it's not gone. Remember, all these are technically becoming 1, so really I have a factor of 1 left over in the numerator. So when all is said and done, this fraction times this fraction will be equal to just simply 1 divided by 3a, right? As long as a is not 0 A is not equal to the opposite of B, and A is not equal to B itself, right? So I'll put this in a box here. Okay, and again, if you want to test this, maybe I'll do this off to the side here. Let's test it with one pair of values that says test. So say I let A be, now again, I can't let A be 0. So I let A be 1, and B, now B, if I let A be 1, this is saying I can't let B be -1 or B be 1 as well. So how about B is 2? That's okay. I can plug these in. And again, you can pick anything you want as long as A is not 0, A and B aren't opposites, and A and B aren't the same. You can pick anything you want. And let's see. Well, if I plug these in to this fraction here, we get, 1 squared, so 1 plus, 2 times 1 times 2 would be 4. So 1 plus 4, and then plus 4 again. 1 plus 4 plus 4, that'd be 9 for the numerator of that first fraction. Then 3 times 1 squared, so 3, plus 3 times 1 times 2, that'd be 6. 3 plus 6, that'd be 9 for the denominator of that first fraction. Alright, times, then the numerator of the other fraction, A minus B, 1 minus 2 would be -1. And then the denominator of the second fraction would be 1 squared 1, which is 1, minus 2 squared is 4. 1 minus 4, that's -3. Okay, so we get, -9 in the numerator divided by -27. That would be 1/3, positive 1/3. All right, 9 goes into 27 3 times, and it's a negative divided by negative, so a positive. Well, let's see, go into this fraction. We'd have 1 over 3 times, and then A, I'm saying, is replaced by 1. That is, yes, that is 1/3, 1 over 3. So they are the same. The product of these two fractions is this little simple fraction here, 1 over 3A. And you can try it out with any other pairs of values of A and B. Again, just so long as A is not 0, A and B aren't opposites, and A and B aren't the same. So I could have A be 5 and B be 7, or A be 100 and B be -10. The possibilities are endless, and you plug them in up here, and you will see that when I plug in the A's and B's up here, this product will be equal to when I plug in A down here just for this little fraction. All right, so that's all I've got. Several examples of multiplying and simplifying fractions, rational expressions, and like I say at the end of all these, just try your best to understand stuff. Read through the text, and whether it be online or in a hard copy, read through it on your own. Try to get things on your own first. Read the material, read examples, try to work out the examples the author gives on your own. Make sure you're understanding them. Work through problems that have maybe answers in the back of the book on your own to check yourself. And don't just give up after the first attempt. People tend to get very easily frustrated when it comes to doing math. I understand that, but try not to get so frustrated the first time around. Don't give up after the first attempt. If after several attempts of a problem or exercises you're still not clicking, try reading through the problem, reading through the material again. Maybe something will click the second time or third time through that didn't the first time. And if after that, it's still not working out, it is not a sign of weakness to go asking for help, go looking for help. Ask a teacher, ask a tutor, ask a friend who knows the material, someone in your class, or look for videos, on the subject like this one, or plenty of other ones out there that are better, I assure you. And just keep at it, stay persistent, and keep practicing, and I know you'll get it, and try to have fun with it. Thank you.